So grade 11s, let us handle our marathon. Hey, I hope you will still be alive at the end of this marathon. Are you energetic? Let's hope you will become at one point. So here we are. We would like to solve, say, question 1. This is where people collect all their marks. I mean, it's algebra and it's paper 1. You collect everything that's available. So you go for it. So there are ways in which they ask you, for example, the first 1.1, it's always, this is the way they ask. So here, if we have this one, you have two things that are multiplying and they're giving you 0. You have two things you're really multiplying and getting 0. So what it means is that if this one becomes 0, the whole thing becomes 0, or it can be the other one, which is 0 and the whole thing becomes 0. So you can go and say, well, either 2x is equal to 0, or you can say x minus 3 is equal to 0. Really, this is the time when life is so simple that, those will be our two answers, just like that. So this works if it is like this, if there is a 0 on the other side. If you have two things that multiply, I've seen people, like say for example, it's x minus 3 and maybe it's x minus 4, but on the other side there is a 5. In this situation, people, you're not going to say, well, either this is 0 or that is 0, or you're not going to say either this is 5 or this one is 5. It doesn't work like that. It works only if it is 0. You get the point? So make sure you know this part. It's not a problem, there's 2 marks. I know that you collected them. And then comes this statement, which gives everything away. Correct to 2 decimal places. Well, they're just trying to let you remember that, you know what, you once did the quadratic formula. Use it now. So your quadratic formula is simple, minus b plus or minus square root of b squared minus 4ac over 2a, right? This is our quadratic formula. First of all, however, you need to have your equation in standard form so that you can get all your marks. So standard form, we mean something of the sort. You see your question is not in standard form, so you are supposed to change it to something of this nature. Did you see me taking 4 to the other side? Well, I put it in the form ax squared plus bx plus c is equal to 0. This, people, is what we call the standard form. So if it is in standard form, then you can see your a, b, and your c. Because this is our first example in this, so I'm just going to ask so that everyone can be on board. Comparing these two equations, what's your a here? And what's your b? And your c? So obviously, when I say let's substitute it into that formula, you're going to say, well, then x is equal to negative b. I prefer seeing the substitution going on. Do not go and simplify it. Apparently, they're becoming more and more strict about these small things. A is 3 and our c is negative 4. So you just want to show the correct substitution into the correct formula so you can have good manners early in life. There is one more thing I have to point out. At this point, most of you will just go to their calculator, get their answer, give it to me to 2 decimal places, and off they go. Well, there is one step that they're needing lately. You need to give me the part where there is b squared minus 4ac. You see this value inside the bracket. Do you see that part? I need to have it first. So you can simplify this part where negative times negative 2, that'll be positive 2 plus or minus. I need the value of b squared minus 4ac, which will work as the discriminant. And we'll talk about the discriminant hopefully at one point in this lesson. So what is the value of this discriminant in this time? If I say whatever is under this root sign here, just give me the value of those things. It is 52, like so. So this step has to actually be there before you give me the answer to 2 decimal places. So you can collect all marks, and if they are undefined, you will be able to notice it from here. What are the 2 answers to 2 decimal places, ladies and gentlemen? Did you say something? 1.54. 1.54, or x is? I can't hear you. There we go. So this, people, is how you collect this kind of 4 marks. Feel free to collect all of them. There is no need to leave anything here. After you do your quadratic equation, please, people, this is your quadratic equation. I hope I'm highlighting the places where you're supposed to go and study. The next thing you want to know about is your inequalities. Well, we did dozens and upon dozens of those inequalities and the different types that are there. But the one thing that is for sure is that for every inequality, the first thing you do is you put it in standard form. Just like the quadratic equation, you have to put it in standard form, factorize it, get the roots. Those are the things you do. In this situation, however, if you look at what we have right now, let me remove everything here. I don't think anyone needs it anymore. So if you look at what we have, I mean, I already have x minus 1. It's x minus 1. It's already multiplying with 4 minus x. They've done the factorization for us, it would seem. You don't have to factorize anymore because here you have 2 things multiplying and there is a 0 on the other side. So it's already factorized. No need to clear out these brackets or anything like that. You just go straight to giving us the roots. What will make each bracket 0 becomes the question. What will make this first bracket 0? What x value? 1, or the other x value for the other side? X, actually, remember, it's 4 minus x, which is equal to 0. As you're noticing here, x will actually be equal to 4. Can you see that? That, people, are the 2 roots that you need. After you get the roots of the equation, now you put them on the graph. We were using the graph. You can use a number line. Really, it will be fine to use anything. So let me just use the graph here so we can carry on. So the graph, we're working with it like this. I would go and draw a graph of these things. And remember, we were not worried about anything about this graph except the shape as well as the intercepts with the x-axis. So our roots are 1 and what was the other one? Was it positive 4? So it looks like the roots, I'm going to put 1 here and I'm putting positive 4 here. Notice if I try, look at this x here. You're seeing this x? The other x I'm seeing is actually this negative x. If you multiply those two, are you seeing you get negative x squared? So in this situation, is the graph supposed to be frowning or smiling? So it'll be concave down. So you need to remember the shape of these things. You do not even need to know where the y-intercept or the anything else is or the turning point. You just need that shape. This shape will help you decide where on these routes, where are you supposed to go? There are 2 places you can actually be. There are only 2 possible answers. You can either be in between the roots or on either side of the roots. So at this point, we already know our roots is 1 and 4. We know that's what we need. But we need the part of the graph that is greater than or equal to 0. The part of the graph that is greater than or equal to 0, is it the part that is above the x-axis or below the x-axis? It should be the one above. So we need this part. This is the part of the graph that is above the x-axis or that is greater than 0. As you can see, the part of the graph that I have highlighted is in between the roots. Okay? It is in between. So our answer, we put x there, and we put this one in between the roots, the smaller one to the left, the bigger one to the right, like so. And because the question has included here, we also want to include our x values. Well, this is just for your haters out there. So you know that, you know that we are working with element of real numbers in this situation. Just for interest's sake, just to see if you're getting the concept, I'm just going to say, let's say you had a function which was like so. I'm just going to put something. Let's say your function was, it was already factorized. Now, let me try to give myself a very simple sum. So I'm going to give myself a simple sum since I love myself so much. So I'm going to do this. Is this going to be fine with everyone? And I'm going to say, let me say greater than 0, you know, for a difference. So this is an inequality, wouldn't you say? Now, what are those 2 numbers I multiplied get 6, when I add I get 5? It'll be 2 and 3, isn't it? So I'll have positive 2 and I'll have positive 3. As you are seeing, my equation was already in standard form. So I'm now factorizing it, and it looks like this. Now I'm going to get the roots, which is what we agreed. So your x will be negative 2, or your x itself is negative 3. So I have my roots. I'm going to do exactly the same as I said before. So these ones are actually negative, so I'm coming this side. I'm going to sketch this graph. So I'll put negative 2 somewhere here and put negative 3 somewhere there. Is my graph smiling or frowning? Smiling one. Our a is positive. So in this situation, our graph will look like this. I'm not worried about many things. I'm just worried about the shape and the x-intercepts. We know that these are the roots. There are only 2 places the answer would be in this situation: below the x-axis or above the x-axis. Remove your sticks from your ears, please, yourself at the back. So what you need to do from here is to determine where the graph should be. So in this situation, because you're solving for greater than people, you're solving for greater than 0, where are you supposed to be here? Where should you be? Above the x-axis again, isn't it? Greater than 0 is above. So again, I picked this part for a reason. You can see this is the part of the graph that we need, but is the part I am highlighting still in between the roots? No, it is no longer in between the roots. How do we answer such a question? Well, this means that x here is, you can see the part I'm highlighting is slant to the left of negative 3. So we'll say it is smaller than negative 3. I didn't include because the question did not include. There are 2 places here, and another one is to the right of negative 2. So you're going to say x is greater than negative 2. So this will be your 2 solutions in this situation. So this is how we have been handling inequalities all along. I want you to carry on with doing inequalities like this. If you are using a number line, feel free, carry on with it. I'm fine with whatever method is making it work. All right, so that is what we have with inequalities. The next sum was not inequalities. Let's see what it was. Is there anyone who is still copying? All right, let's go and do the next sum. I'm going to remove all ink on the board, so if there is something you need, you better take it out just now. All ink is about to leave. All right, so look at what we have here. 1.14, now we're working for 5 marks. This is beautiful. And as you are seeing, what type of a thing is this? Surd equations. Yes, for surd equations there were just 3 rules we were supposed to remember. The first thing I say, well, isolate the surd. After you isolate the surd, what will you do? Square both sides. In this situation, it is already isolated. Can I just go and square both sides? Right there, I'm squaring both sides. Please, people, when I say this squared, if you square this one, 5 minus x, and then you square it, it kind of cancels the square root sign. It's raised to the power half squared. It will cancel the root sign. Then we have x plus 1 and x plus 1 and x plus 1. It means x plus 1 squared. Generally, this is what it is. So I'm going to put 5 minus x here and carry on. For the love of those ones that may have forgotten how to FOIL, can we go for it? X times x? And what about x times 1? And then 1 times x? So it's 2x, I hope you noticed. X, and then 1 times 1? 1. So we don't do it that way. At this age, it should happen very fast. Square the first term, multiply the 2, double the answer, and square the last term. All right, so in this situation, I believe everyone is aware of what's going on here. This is going to be plus 3x. What is 1? Is that 1 minus 5? What will be that answer? Negative 4. I'm ready to factorize this one. I hope there is someone out there who knows 2 numbers that we multiply to get 4, negative 4 actually, and add to get positive 3. What are those 2 numbers? Did you say something? The bigger number should be positive and the smaller number negative in this situation. So you got your answers, it would seem. X of negative 4 or x of 1. Most probably you'll be like, yeah, I'm done now. Are you done? Yes. Not really. You have to do your testing. Yes, you have to test. These are surd equations. You don't go until you test if it's working. So 4 marks, you already have 4 marks. The other mark is to check if this is working. So you may wonder, how do we check that? Well, you go to the original equation, this one that we started with. And just to make sure that everyone is seeing this, you're going to go to the left-hand side. Let me just substitute the one that is, say, -4. So I'm going to substitute -4. I'm checking if -4 is working. So I'm putting in place of x -4 for the left-hand side, and I'm doing the same for the right-hand side. So I'm going to say -4 plus 1 as well, and see if these two sides are going to be equal. Who knows what 5? It's going to be 5 plus 4. Can you see? So it's going to eventually be square root of 9. And remember, for these ones, we only take the positive one. So it's 3 this side. And minus 4 plus 1, what is that? -3. Already, this is not equal. So you get a mark for canceling that out. So -4 is not working. Did you try 1? I'm not going to do everything. Is 1 working? So in this situation, the only solution that was there was x of 1. You couldn't take away if you leave x is equal to -4 as a solution, you are simply going to lose that 1 mark. So people, this is the first part of algebra. Really no stress, just you collecting marks and adding them to your life right there. Let's go and finish it off. There is this darling that should never be forgotten, the simultaneous equation. It's really irresponsible for a lot of marks that we get in our math. With this one, it's a simple procedure because we just said in grade 11, the main method that is being used is actually substitution, and I've noticed you like substitution particularly. So just so we can be together, I'm going to call that one equation number 1. I'm going to call that one equation number 2. Are we together, ladies and gentlemen? Are we going to form a third equation? I said use the linear function, the linear one, to form the third equation. Figure out which function you should make subject. I also say to you, get the one that has a coefficient of 1 or the coefficient of -1 to be subject of the formula. So in this situation, which one will you make subject, x or y? It will be x. That will be easier. So in this situation, I believe you're going to say x, leave x alone on the other side and say 2y minus 4 and call that one equation number 3. The joy we have is when we start putting equation 3 into equation 2 and solving this. We're going to do it just now. So look at how we're going to do it. Wherever I see x, I am going to react. So far, I do not see x. I am copying equation 2. Now I am seeing x. When I see x, people, what do I replace it with? Oh, yes, 2y minus 4. That's x. And then at this point, you're noticing that there is y then afterwards, and then plus 21 is equal to 0. Right, this is substitution. It is a full mark. There is a full mark for making the third equation, another mark for substituting the third equation that you made and put it here. So far, you already have 2. You're just left with 4 to get them. At times, this thing is 7 marks, and it's really simple. Now let's go and simplify this. I believe everyone is fine with me writing y squared, and then we are at that place where I normally have a problem. Do you see where that y is right there? I usually like for it to be on this side. I like to move that y from where it is to this side. You see that? So that either you move it in your head or you really move it for sure, so that your expansion will be easier. What is minus y times 2y? Negative 2y squared. I believe that is a plus. 4y plus 21 is equal to 0. Let's see how this thing will go. Am I getting minus y squared now? Just make sure I don't do addition. You will enjoy coming back to whatever I have added myself. So at this point, what do we do? Can we factorize like this? It's better to? Yeah, let's divide by -1. It will work. So we're going to do y squared here, and then I'm going to say negative 4y and say negative 21 and say is equal to 0. Feel free to get me the factors of 21 that will add to give us negative 4. Factors of negative 21. The bigger number should be negative. y minus 7 and y plus 3. Obviously, everyone can see now that we have answers. We have two answers, y of 7 or y of negative 3, isn't it? So we have those two answers. So the main thing now is to get the other. We are solving simultaneously. It's not enough to get y. You also have to now go and get x. So that is where our third equation works. Who remembers what x was again? It was 2y minus 4. So we are saying just go and put, say, y of 7 and do stuff like this. As you are noticing, your x will be 10. So 7 will work with 10. And what is the x value that will work with negative 3 for those ones of us that are fast? It will be negative 10. Okay, so feel free to substitute negative 3. You should get that one. So we have this pair here, and then we have this pair over here that's working. So certainly you get all your marks for doing this. If they don't want to bother anyone, they will just give marks on the answers themselves. Getting x of 10 has its own mark, y 7, y negative 3. But I would rather you get marks for your method, because if you accidentally get to the answer, I normally do negative marking as well. So please make sure you're using the correct methods to get to where you want to get to. All right, people, that's simultaneous equation. Unfortunately, with the time we have to move fast so we can cover a lot of ground. If you do not understand, however, feel free to ask. I can take care of a question or two, you know. You get the point. Perfect. Let's go to the next thing. Then the next thing is, those nature of roots. Nature of roots, I may have to remind you something here. I'm going to remove ink again on the board so we can work together. Are we done with this? All right, with nature of roots, just so you remember, there were 3 things I said. Let's have these notes here that will help you to remember everything. So with nature of roots, remember the quadratic formula? X is equal to plus or minus b, Let's remind each other quickly. Minus b plus or minus square root of b squared minus 4ac over 2a. Do you still remember this formula for the quadratic formula? Well, I said the nature of roots back then. I said the nature of roots is determined by the discriminant, the part that is under that root sign. It's the one that determines if we're going to have equal roots, non-real roots, irrational roots, or whatever it is. So we call this one the b squared minus 4ac, the discriminant. So what is it that it must do for certain things to take place? So here is the thing. Number 1, I said this discriminant can be greater than 0. If it is greater than 0, know for sure that the roots are real and they're unequal. There is a third one that we will add, but those are the things we know for sure. When we get our a, b, and our c, and we substitute in there, and we get a value that is greater than 0, it would determine whether it's, actually we will know immediately that we have real roots. And while we are still at it, why don't I just tell you this one, because it works together, this one, because both of them are real. There is one thing in common here. If it is equal to 0, the discriminant, the thing is real, but for this one, there will be equal roots. And let me just add this whole rational thing. You will understand as we go why I'm putting it there. Let's go to number 3. Theory. This part I'm just reminding you the theory you already know. Well, there is a time when you work it out and you get something smaller than 0. Now, that would mean that these are non-real roots. You no longer have to describe anything anymore. Once you realize maybe your discriminant is negative 10, you stop right there. There's no need to carry on. It's non-real roots anyway. And then the last thing is when you realize that your discriminant is actually a perfect square. If it is a perfect square, then something happens. Already it will be real here. Most probably you get a perfect square like a 4. Do you see 4 is already greater than 0? So you already anticipate, you already know that you should have real roots and they're unequal. There is one additional thing that takes place if this is a perfect square. The roots will become rational. the roots are rational. And in case you've forgotten your grade 9 rational, this is a rational number where a and b are integers. 3/4 is a rational number. 5 is a rational number because it's 5/1. 7/10 is a rational number. Square root of 2 is irrational. If you cannot change it into a fraction with an integer on top and an integer at the bottom, that thing is irrational. All right. So this is the theory you need, okay? This is the theory you need to handle what you need to do. What then, how do they ask you? Maybe let me just throw in one question, because you might be wondering, oh, okay, I see the theory I need, but how do I go about it? Well, they will just give you a normal equation. They have levels, these things. If you remember when I was teaching you, I'll say, well, this is a level 1 type of asking. This is a level 2 kind of asking. If you check your notes, that's exactly how things are arranged. So if you have something like, if ever it exists, I'm just going to do something here. I'm just going to, I hope it works. So at this point, I'm just thinking of numbers, really. So let's just do this and say is equal to 0. For all we know, we do not know if this works. What is A here? And B? And C? All right, good. So what I want you to do right now is to get your discriminant. Remember, it's b squared minus 4ac. We want the value. They will say, without solving the equation, describe the roots. So in this situation, let's just go and find it. Our b is 4. So I'm hoping there will be something good coming out of this example. Our a is 5 and our c is -7. So someone with a calculator and is serious about life, give us the discriminant, please. Did you say 156? Right. Please, people, if I am asked to describe the nature of these roots right here, I already know that 156 is greater than 0, don't I? So I have one thing, it's real. And because it's also not equal to 0, I know the roots are unequal. And here is the annoying part. Is 156 a perfect square? If it was 144, we were going to say yes. But now 156 is not a perfect square. The next perfect square should be 169. So in this situation, the roots are irrational. That's what we mean. So you would have described the nature of roots by doing this. By looking at an equation and without solving, you can actually describe the nature of roots. Let's go and answer the question now. That's the theory I needed to remind you first. All right, from here, let's go now to whatever this question is asking you about. Now we have to discuss the nature of roots for this equation over here. Is it in standard form, people? Can we see A, B, and C easily from there? Yeah, we have to do a little bit of work, unfortunately. So let's go and do it. We're going to have to try and put it in standard form first. I believe this is exactly what you... Oh, did you see that? Sorry, there's the bracket. It's still here. So can we handle the bracket properly now? Notice we have to say x minus 3 squared. What does that tell me? Minus 6x plus 9. And then, well, we have that plus 2 is equal to 0. Certainly, you need to first of all do stuff like this. I believe that's negative 12x. Is that 18? It's a 2. Now, according to what I have here, I believe I have now the equation in standard form should look like this. Is this not, I feel I lost an x somewhere. Did I? Okay, so is this minus 12x? And then 8 plus 2, 18 plus 2. So we have 20 like this. Here is the place. Oh, they know. They are very good at what they do. Do you see that there is that common factor of 2? Oh, it's very tempting. Don't do it at this point, because what you want is your b squared minus 4ac. You don't want to try and solve this equation, so you want to use the very same values at this point. So here is what we're going to do. Let's go and find the discriminant together. How many of us can see their a there? Yeah, I'm interested in getting this. This is what I want. So I am going to put a b of negative 12 and say minus 4 and put a 2 and put 20. So at this point, what is the value of the discriminant, people? Did you say negative 16? Why? It was going to be so good if it was positive 16, isn't it? As negative 16, we have just one description for it. Non-real. So we're not going to do much. If it was 16, it was going to be a joy. What were we going to say if it was positive 16? We were going to say real, we were going to say unequal, and we were going to say rational as well. It was going to work. But since it's negative 16, well, the explanation or the description is non-real. Discuss the nature. Don't go and write an essay and say I'm discussing the nature of roots. Nobody would like. Okay, these questions, they should use different words. Other people, should we say discuss, they go for it. They turn their desks and they start discussing with the next person. And oh my goodness. Yes, dear. Oh no, once it's non-real, that's the only thing. If it's it has to first of all be real for it to be irrational, you know. So we are simply not going to do much there. Can I do the last one? It looks like you were served with something spicy, yeah? Can we do the last one? Determine. Feel free to keep quiet now. So determine the values of P. I'm listening to you. It's a problem if I start listening to you and not you listening to what I have to say today. Right, people, look at this, 1.4. Determine the values of P if Gx has a maximum value of that. Are they not good at what they do? People, if you look at this, let me remove all of this. If you look at this one, we're going to do functions in a minute, but I hope you're noticing it's a parabola of some sort. Can you see it? Yeah, it's a parabola of some sort. So it means, just for you to understand the question, I'm going to start answering it now. I have a few. So here, if you look at this, it's obviously a parabola like this. I knew it was supposed to frown like that because of the negative 2 before the x squared, isn't it? So it's fair if they start asking about the maximum. It's only fair that they should do that. The only thing they did, however, was to tell us the maximum value. They did. They told us that the maximum value at this point, what is it? What is the maximum value? How I dislike a mixed fraction. You know, it looks, what is 3 and 1 over 8? Can we quickly change it? 25 over 8. It looks better like this. Now, what should we do? If it has a maximum value, determine the values of P if this thing has a maximum value of 3 and, yes, dear? It's over 8, right? Oh, yeah, thank you. Is 3 and 1 over 8, you're going to say 8 times 3, that's 24, plus 1, that is 25 over 8. If you use a calculator for this one, believe it, your calculator will tell you something else. It's not able to change these mixed numbers, unless, of course, if you use that SD button. What would you think of doing in this situation? What would you think of doing? Substituting. How do we get the x value of a turning point? Negative b over 2a. Well, you had to. I'm thinking you could have tried to complete the square, or you could have used x is equal to negative b over 2a. Okay, so I'm just going for the person who used that for now. So let me go with this child who remembered this one. Maybe you're good with your functions and you remember that this is how you get the x value of the turning point, right? So here is what you're going to do. The value of the turning point will be minus b. How many of us are noticing that your b is negative p? Keep looking, because this is important. It would seem 2a and 2 by negative 2. So the x value at the turning point, it looks to me like it is in terms of p, which is actually a good thing. This is going to be positive p, but it's negative 4 at the bottom, so can I just write it like this? So what we know is that when x is minus p over 4, this is the x value, minus p over 4, the y value will be 3 and 1 over 8. That's exactly what the question is letting us know. But what do they want? Well, they want to find the values of p. They want us to find the values of p. How are we going to do that? Well, I'm going to ask you this one question. If we didn't have that y value, what were we going to do? Let's say we were finding the turning point. We were going to use x is equal to minus b over 2a, and we get our value of our x. Maybe x was 5. What were we going to do to get the y value? We were going to substitute that value of x where? Into the equation of gx right now. So let's do the same. And then that's how we just want an equation at this point. We want an equation that works. So if we didn't know y, here is what we're going to do. To get y at this point, we were going to say, well, negative 2, and we substitute this one, which is minus p over 4. I'm going to square it, minus p again. In place of x, I'm going to put minus p over 4. I'm substituting the value of x so that I can get the value of y. But in this situation, don't I know the value of y? What is the value of y? 25 over 8. So I'm going to remove this y now, and I'm going to put the 25 over 8. And the moment I have an equation, I would know that, well, the sum has been defeated now. Because from here, the only thing that's missing is you getting the p-value. So we are going to try handle that algebra and see. There is always that one question, people, that will be more than others. They don't just give you everything easily for algebra, but there's always that one last or two questions where you actually have to think. So in this situation, let's just move slowly a bit here, because there might be a few problems that may arise. I feel like, are you seeing that this should be 16 though? What is 4 squared? Do you see this 4? It's also squared. So that's why we have a 16. So that's why I said it's good to be careful in this situation. When we multiply these two, it's going to be a plus. They were not fooling around at all. Okay. P to the power. Oh, thank you. This part right here, isn't it? Because we have negative p over 4 and then it's squared. So p should be squared. I was looking at the 4, obviously. So at this point, it's, let me repeat myself because maybe someone got lost. Do you see this negative 2 over here? Do you see this negative 2 here? It is this negative 2 here. Where did I get the 16? Well, I said 4 squared, okay? And then when we say negative p squared, what do we get? P squared. We are together, right? Then let's move forward. Negative p times negative p, what do we get? That's p squared. Do you see the 4 at the bottom? That explains this 4 right here at the bottom. And I'm going to say plus 3. All right. At this point, we are just really going to multiply by 16 here. Can you see that's going to be the lowest common denominator? We can multiply everything by 16. So I'm not going to show that step. So, or maybe I should for that one child. Who knows? So there is a 16 I'm multiplying with for this term. So do you see that 8 will go there 2 times? So I'm just writing 2 times 25. I'm going to multiply each term by 16. So it's equal to, if I multiply this term by 16, this and that will cancel, right? So I'll have minus 2p squared. If I multiply this term by 16, 4 goes into 16 how many times? So there will be 4p squared here left. And I'm going to multiply this by 16. What is 3 times 16? 48. algebra. Let's finish it off. I would like to leave a 0 this side. I'm going to say 4 minus 2. Is that 2p squared, ladies and gentlemen? Keep looking, because adding is not for me. Are you here? Okay, the 48, are you seeing 48? So this is a 50 here. 2 times 25, that's 50. So obviously I'm going to take it to the other side. 48 minus 50, that is negative 2. I seem to have a 2 happening twice here. Let me take advantage of it. I feel this is, I can divide by 2. It's not like dividing by x. I can really divide by 2 here and things will work. Are you fine? All right. So finishing it off. Here we have 0 here. Can you see on this board? P minus 1, P plus 1. Right. So now we got our P values. Another thing was for you to just say, you could say at this step here, you are not forced to go the way I went. You could say P squared. You may be quiet for now. P squared is going to be equal to 1. And P will be the square. Let me write it here. P squared is equal to 1. Obviously, P will be square root of 1, which will be plus or minus 1, isn't it? You can do that. Okay, let's go and figure out what the question wanted. I think we wanted to find P. Let me see. Determine the values of P if Gx is that, P was supposed to be plus or minus 1 in this situation. But let me give you time to swallow the sum. I feel you need. Completing the square was going to be even bad, isn't it? If this is like this, I mean, completing the square wasn't going to even take us anywhere close. If you were in grade 12, I was going to say let's do calculus, but it's not necessary for now. Look at question 2 for this year. We are actually doing the November 2019 one. In case you're wondering, that's the question paper you've got end of year. So look at what we have right now. The thing is, when we did stuff like this, now you know where to go and look now. What is it that I must know? We did exponents, and there was a time when I was saying one term. We are doing exponents that are just one term, and then we were simplifying those. This is the type. It's one term. Why am I saying so? Between these bases, can you see their multiplication signs? There's not a plus in between. So let's say there was something like this, 3 to the power x minus 5 by 3 to the power x plus 1, and then maybe something with 9 to the power x plus 2. Let's say it was like this. This won't be a one-term sum. Here you would do factorization. You were likely going to do something. Let me do what you were going to do here so you can see the difference. If it was like this, notice on the numerator there is that negative there, hey? So you were going to actually try to factorize what's common for this one that I just threw up there, and you were most probably going to say something like this, 3 to the power 1. Are you seeing what I'm doing? So there must be a 1 here, minus. Are you seeing this? You are, right? Okay, and then at the bottom, and this is, I think I put myself in a situation where I won't be able to get out of. So that 9 is going to change into 3 squared, and that's not what I wanted. Let me put a 3 there so it will solve easily, because if it becomes 3 to the power 2x, then I'll have to explain other things. There's something we did that was called the K method. I hope you still recall. So it will be something of this sort. And then we will cancel that and we carry on. The question will likely be evaluate, or it's unlike the simplified type of questions where you may have an expression or you may have a value at the end. So this is what you are going to do if you had an expression like this. But what am I saying? What are you going to do now in the situation that you find yourself in, which is here? Well, this is a one-term expression. So if it's a one-term expression and your bases are not letters, remember they can give you letters as bases. But in this situation here you have numbers, so just change your numbers to prime to prime numbers. These bases, they should be prime bases. Like 3 is already prime, so you leave it as it is. So it'll be 2x plus 1. And 15 is 3 times 5, like this, right? And 3 and 5 are prime. Then you have 2x minus 3. This is what you must recall, obviously. 27, what is it? 3 to the power of 3, and then you put it as x minus 1. And it's already 3 to the power of x, and 5 to the power 2x minus 4. There was a time when this was new to us and it was very exciting. I hope you still recall those moments. So please, people, what we would do in this situation, we will first of all clear the brackets, remembering the one rule of clearing the brackets that we were using. So I say to you at one point, I said, if you have x to the power, let's say a, and it's raised to the power b, is the same as actually saying x to the power ab. Is that fine? You practically multiply the two. So it's the rule you're going to use in this situation. Let's leave 3 to the power of x plus 1 here. I'm going to, I don't think I can do this slowly. Maybe let's try to do it slowly. So 3 here, and then we have 2x plus 1 over there. And now 3, we have to distribute. 3 has to get the exponent of 2x minus 3. You're seeing that, right? And 5 also has to get the exponent of 2x minus 3. That's another law that we are using there. And then at the bottom, as you are noticing, now this 3, can you see the 3 I wrote now? Right, this 3 to the power 3, it has to multiply everything, the 3. 3 has to multiply x minus 1. So it will be 3x minus 3. Are you fine with that? All right, and then we have 3 to the power of x here, and then we have 5 to the power of 2x minus 4. So these two steps, according to me, those are the important steps. Everything else from here is just a matter of taking the base and subtracting and all that and all that. So I'm going to go and do that just now with you. I'm gonna do that right now. So why don't I do so quickly? So I'm going to go and say, let's take one base and handle it. Since it's one term, this is how we were doing one term. We would take one base, say of 3, and then I'll take everything that has 3 on the numerator. Notice I have 2x plus 1, and I also have, you take it together with its sign, you don't change anything. It's like you're adding everything. I've taken this one and I've taken that one. That is the base of 3. On the denominator, there is another base of 3, which you are noticing is that one and that one. For the denominator, however, you have to subtract. So to do that fast, you just change the sign of the exponents. So this is 3x minus 3. You write it as minus 3x plus 3. Are you seeing that? And then this x here that we have here, positive x, how do you write it? Negative x. I'm done with that part. Now let's go to the base of 5. You just multiply it with the base of 5. Things on the numerator, they come as they are. So I'm going to take 2x minus 3 as it is. If there is something at the bottom, which there is, I'm going to change it to minus 2x plus 4. Are you here? So that's the part I want you to remember. So once you can do one of these things, you can do just about anything actually. And a small mistake can be very costly on this one. So here let's just add 2x, is that 4x? Unfortunately, the x's are cancelling out. It's actually a good thing. There are ladies in front that have to be reminded to take it easy. So what is 1 minus 3? Oh, and then there is that plus 3. Can you see it's going to just be 3 to the power 1? Am I good? All right, then let's go to 5. Again, these ones are cancelling. And then what is minus 3 plus 4? 1. People, if you have something like this, even you will be confident about yourself. What is 3 times 5? You can simplify this one to 15. If it was 3 to the power 7 times 5 to the power 16, you are going to leave it like that. You're not going to bother yourself, because some of the times the questions will be saying without using a calculator. So you don't even want to appear as if you have a calculator at all. All right, so that is the first time. I believe there must be one or two or three or maybe all of us that got that one right. So that is what I want you to also go and check these terms as well. Let's go to the next thing. Yes, dear? Repeat that. You were not done copying. Please hurry up. Copying is very important and you should have all your things ready. Right, I need to do question 2. Who is that person who I have to remind to keep quiet? Who else? That child there. You're stopping. Actually, you might be wasting other people's data as well at this point. This will not be cut. Nothing will be cut here. Should I say your name? Okay, never mind. Okay, so in this situation, people, we have this part. This is the first type of equations that we have where we change the base to the same base. Very, very simple. So you have 32, you can change it to something, and you have a half which you can change to something. 32, how can you change it to prime bases? Yeah, just make sure you have the same base on the left as you have on the right. So since you're saying 2 to the power 5, I believe then you are already thinking half can be written like this. Is this fine with everyone? And then I'm going to write that one as 2 to the power of 5. So after we do this, this is likely going to be a problem after some time. So this is going to be 2 to the power of minus x. Are you seeing this? Now, what do we do now that the bases are the same? We equate the exponents. So the exponents will be the same. Therefore, x is going to be equal to negative 5. That will be our solution for this one. I mean, for 3 marks, I don't even know. Like, why 3 at this point? Even 1 was going to do just fine. I mean, sorry. So much work. There was nothing that was done there. Let's go to 2.2.2. I'm ready for 2.2.2, ladies and gentlemen. We have a small problem there. You have to remember 2 things for me. There is this one. You have to remember that when we say x to the power, how do I say this? Negative n is the same as saying 1 over x to the power n, right? Do you see what I'm doing here? And then you have to remember this part as well, where if I have the nth root and then this is x to the power m, when we were changing these terms to things that have exponents, what was the answer here? What would be the answer for this one? M over n. Whatever is over here becomes the denominator actually. So in short, I am saying if you have, let's say, square root, let's not use square root, let's use 5th root, just to make it interesting. 5th root, can you see this will change to x raised to the power 7 over 5. Yes, so those are the 2 things I believe you needed for this question to work. So if you remembered something like this, you must and then, well, we did certain equations that we're calling radicals. So we were handling those ones as well while we were younger in term 1. And now I think a lot happened between January and now. So let's see here if we can do something. I want to do it like this. You can do it differently, by the way. Nobody will ask here. Is equal to 4. Firstly, are you happy with what I did? Okay, the next thing I'm going to do is I'm going to lose that root sign. Now I'm going to call it minus 2 over 3 now. And I'm going to say is equal to 4. Can I write 4 as 2 squared? Happy? Right. When we get to this step, this is the part where we were doing some radicals, actually. When we get to this point and we need x, who remembers what we were doing? Let's see. Yes, we were raising it to the power of the reciprocal of that exponent. Yeah, that is what was happening. So what I'm saying, let me leave that step alone there, and I'm going to do this. I'm going to do this quickly. I just copied that first. I am going to now raise to the power of a reciprocal. The reciprocal will be 3 over negative 2, but I would like to just write it like that. Whatever I do on the right and on the left-hand side, I'll do it on the right as well. With one exception here, we have just one little problem of those that are not listening. Pointing fingers won't help us eventually. What will help is to understand this. There was one rule that we were doing. Did you see us taking the reciprocal? Well, let's get our x. Of course, we will get x when we multiply these two here. We will definitely get 1. So it will be x to the power 1 eventually. There was a thing I said at this point about certain roots, but before I do anything, can I just do what you can see right now? Can you see 2 and 2 will cancel? So the answer will be 2 to the power negative 3. And what we know about 2 to the power negative 3 is that it is 1 over 8. 1 over 2 to the power 3, which will be 1 over 8. But what is that one thing that you have to remember when we do this part? All right, so there were those rules, you know. At this time of the year, you may have already forgotten them. Okay, there were times when I would say, well, we need to have 2 answers. And that time, if you recall, it was about the numerator. There was a time, if the numerator is even, there was something that was taking place. Here we are talking about these equations where the exponent is a rational number. So you have a rational number here, and the numerator happens to be even. In that case, you have 2 answers. You remember that? So what we have, if you look at what we have right now, we started with x to the power negative 2 over 3. So it's really, can you see the 2 is an even number? So at this point, you should have 2 solutions, isn't it? That will be x is equal to plus or minus 1 over 8. However, if it was a third, was it a third initially? Now, this is a problem. Once you see this part, however, this thing, you have to go and test if your answer is going to work. You go to the original one. Where is the original one? Here. You go and substitute one of them and see if it is going to work for both of them. So this side, please do 1 over 8. And this side, okay, maybe this side again, do a negative 1 over 8 as well. So try to do it as fast as you can. Do you have the answers? You are just wrongly placed there, ladies, trust me. What is the answer? Ladies, you are the only ones we are relying on right now. If you don't say anything, this side is not going to survive. Are they working? Both of them. Okay, if both of them are working, then it's sorted. Otherwise, we're going to choose the one that's positive or leave the other one. People, in the interest of that one, while we are just talking about this, can I just say one more thing? Remember, this was a numerator, which was an even number. So there were 2 answers. What did I say when the denominator is the even number? There was something I said. And I said it a long time ago. I'm sure you've all forgotten. Yes, what did I? It should not. So if it is x to the power, whatever this thing is, if it is an even number here, okay? If the even number is at the bottom, let's say it's 1 over even, it cannot be negative. It cannot be negative. So if you have some negative number here, that is not going to be a solution. So there are times when you actually have to handle that. So you'll be working on something like, maybe you got 2 answers, maybe x squared, let's say it was x to the power 1/4 was equal to maybe 7, and then you have another answer which is saying x to the power 1/4 is equal to negative 3. You go and you cancel this one. It's not going to work. because it does not work if, it shouldn't be negative if the denominator is an even number. This one you just carry on and you say, well, I'm going to raise to the power 4 and raise to the power of the reciprocal on both sides, and you're going to get your answer if you are at this point. So these ones, we did these ones, quite a number of them, while we had time. At this point of the year, really you do not have time to go through every other example we have done, but you just have to remember the laws and see if it comes, then you know what to do. What is 7 to the power 4 now that I'm already here? 401. So our answer, if this one, 2401. Okay, well, if this was a question, well, this would be the answer right here. I would like to go and finish off what we started, people. The answer was 1/8, or was it plus minus, whatever. Now let's go to 2.23 right there. I am ready for it. I hope you are. Now, yes, dear. If you cube both sides, for which one? You will get to the final answer as well. Yeah, you got 1/8, right? Yeah, you should get. It was just the method I used. May I just do the one that he is suggesting so everyone can work there? Are you seeing what's happening there? Please. So look at this. He has already said, people, if it was just a square root of x minus 1 is equal to 7 or something like that, is equal to maybe x plus 3. Do you know that we're going to square both sides at this point? In this situation, let's try and use the same method. He's saying, since this is the third root, can't we just cube both sides? And I'm saying, yes, we can. We can do that, and it will be very simple. So if we cube both sides, we are saying raised to the power 3, and we are saying raised to the power of 3. Right. So at this point, we will have 1 over x squared. And then we have, what is 4 to the power of 3? What is 4 raised to the power of 3? 60. Okay, so we will have x to the power negative 2 here, which will be equal to 64. What is 64? Anything squared? Or whatever, what is it? 8 squared. What should I do here? Or 2 to the power of 6, really doesn't matter. I'm just trying to take the short way. So I'm going to do this. I'm just saying x to the power minus 1 should be 8. In this situation, 1 over x is going to be equal to 8. Means x itself, 8x is 1. It means you are getting one solution for this one, isn't it? Yeah, I'm sure eventually x is equal to 1 over 8 should be the final answer. The people that checked may have checked incorrectly. Are they both working? And what about the negative one? Is negative, or is it squared? So it's gonna work anyway. Oh, okay, perfect. All right, I'm gonna go to 2.23, guys. That was my mission, actually, to go to 2.23. I just thought I should show that this is correct. All right, so for 2.23, there is something repeating there. This type of exponents, you just have to know what to do when it comes, the exponential equations. This time around, for this one, there is something repeating itself. What is it? 2 to the power of x. What did I say you do if you see something repeating it? It means it's another form of k method. So you're going to let k be whatever is repeating itself. This is Floyd. Is it fine if you keep quiet wherever you're seated there? Right. So if you have something like this, so we're going to go and say k at this point minus 12 over k is equal to negative 4. Are we seeing this part? Now what do I do from here? Am I stuck now? I'm going to multiply everything by the LCD, isn't it? Which is k. So just in case there is that one child, we have 3 terms we are multiplying by k there. So this is what's happening. So if you say k times k, what are you getting? So there is k squared. Are you seeing that k and that k will cancel? So we will have that negative 12, and then on the other side we have negative 4k. So this is what we are working with right here. And then, of course, now you can see everything was reducing to a trinomial back then. A trinomial was quite a thing when we started learning about it. When we did algebra, we realized everything was going and becoming a trinomial. So now it's your job now to think of two numbers you multiply to get negative 12. When we add, you get 4. What are those two numbers? The bigger number should be positive. Positive 6 and? Did you say negative 2? All right. So as you are noticing, your k will be negative 6 or your k is positive 2 in this situation. So you got your two answers for k. But don't forget, well, nobody asked you for k. In fact, you made it up yourself. So what should you do right now? What was k? 2 to the power of x. Now, here is another rule again. Notice you're going to equate it to negative 6. And already you should see something you should start itching already, because at this point that is never going to work. So 2 to the power x here can be equal to 2 as well. People, concerning this first statement, is 2 to the power x actually ever going to be negative? No, not for this one. We know the graph for 2 to the power of x is always above the x-axis. It doesn't even cut the x-axis, let alone negative 6. So that one cannot be negative. This one, however, you can go and say, well, put a 1 there, and what is our x value? So this is how you sort these things out. It was another form of the k method. And while I'm still on the k method, can I just remind you the other type of k method we had? So it would be something similar to this. We are not going to solve it since it's just erupting from my good head. So it would be something like this. Maybe 2 like this minus 4 is equal to 0. Are you seeing this? Are you seeing what's happening here? There was some form of doubling of exponents. So this part here was to the power 1x, and this part was to the power 2x. Which one will you which one will be k here? You will go and make it 5 to the power x. So in this situation, it will be 3k squared plus 2k minus 4 is equal to 0. Don't try to solve this equation. It may not work at all. Remember, this was the k method we were doing back then. A lot of these, what was happening? The exponent was doubling. So go and check those ones as well. I think I've been sending you. Yes, my dear. For that top one, for the top one that we just finished doing, it must work as well, as long as you are going to fight the algebra to the end. If you're not going to make an algebraic crime there, you should get to the answer of x is equal to 1 as well. However, I wouldn't recommend that method. Let's go to the last one, people. Getting 20 marks is very simple around here. So far, we already have 46 out of 100. I mean, it's already a pass mark. That one was 100 marks. Okay, so looking at what we have right here, let's go and do 2.3. What do you think? What do you think we need right here for 2.3? What do you think we need to do? Someone is saying, let's multiply. Take it to the other side and multiply. Okay. So let's just do one thing. As long as we are moving forward, it should work. These things, you just have to be there for them. If you are going to be there and not make mistakes, chances are you'll get to the final answer. So what do I mean? I was going to rationalize one at a time. I was going to rationalize the term on the left and rationalize the term on the right separately and get my answers. I'm sure that. Can I do that first? I mean, so you can remember rationalizing. So I'm going to do it the longest way possible, but at least I'll be reminding you what we were doing when we were rationalizing. So I'm going to take this one. I'll take this expression here. and rationalize it. Let me start with this one since it's the easier one. Are you looking at this one? There is one term on the denominator. When there is one term on the denominator, I said you multiply by 1. Either ways you be multiplying by 1, but the one here is simple. Are you seeing the one we are multiplying with? So here it will change to 4 root 2. What is root 2 times root 2? 2. And now there is something to simplify again. What is 4 divided by 2? So it will be 2 root 2. Okay, I got that one as 2 root 2. I rationalize that one. So I'm going to come and rationalize this one as well. When there was more, we are rationalizing the denominator. So if it is one term, it's very simple on the denominator. But if it is two terms, now there were some laws you were supposed to remember. Like, for example, you still multiply by 1, but it will be to make a difference of 2 squares, isn't it? Well done. So it will be now with a different sign in between, like this. It's still 1, except now it has a different sign. So this is what we were doing back then. So again, I want you to remember how to do stuff like this. So let's go and let's handle this quickly. I'm going to do it on the numerator. What is root 2 times root 2? And root 2 times negative 1? Negative root 2. All right. The bottom part, you can actually FOIL if you want, but that's not what I recommended back then. I said square the terms because the middle term will cancel. The middle terms will cancel. So what I said was take the root 2, take the bracket that's negative. So this is the bracket that's negative, right? Square the terms only. Square that one, say minus, and say minus 1 squared. That's instead of foiling. In fact, even if you foil, you come back to this step. If you are still understanding, I'll carry on. So I'm going to go now on the numerator. Look at it. We're on the numerator. So it's going to be 2 minus root 2. Just for interest's sake, what is root 2 squared? That is just 2 minus 1. And you know, it's interesting. 2 minus 1 is 1. So eventually we are going to have 2 minus root 2. Don't forget, I simplified the terms. I simplified the first term, I rationalized it, and I went and I rationalized the second term. Don't forget, these terms were adding initially. You remember? So if you remember, this first term, we simplified it to what? The first term. It was 2 minus root 2. And the second term, we simplified it to 2 root 2, like this. Are you seeing some like terms here? What is 2 root 2 minus root 2? It is just root 2. Exactly where they wanted us to go. So I don't know if you were going to do it like this. Rationalize is just you rationalizing the denominator actually. So here I just reminded you the whole process of rationalizing the denominator. What was going to happen, people, if we were to take the two fractions together and simplify later? Can we do it like that just to see? Are you up for it? It will be longer than this. Oh, okay. Well, other people that did it are actually warning us and saying, you know what, that would be very long. But I don't want to, you just wait for when I'm done and then you can always. All right. So what I want to do right now is just to do it. And then let's see if things are going to work here. Let's see how long it will be. Did you manage to copy everything? There is one child who has to copy. Let him copy. All right. Do not forget, I like fast students.